The wiring and train control strategy used on the Apple Valley branch is a sophisticated digital command control system. The basic theory of command control is that each locomotive has an electronic decoder in it, and even though the track is receiving a constant voltage, only the locomotive selected by the engineer will run, even if there are 100 locomotives on the track. Added bonuses are that track wiring is so much simpler and train control is much more like the real thing. Details on conventional wiring is discussed in books from Kalmbach Publishing and Atlas that cover this subject. What is needed for being able to control more than one engine at a time is to run a separate pair of wires from each throttle to the track. In this example, there are 2 throttles in 3 sections or blocks of track. A double-throw, double-pole switch is connected to each block so that locomotive A or B can be selected. The block size is determined by how much control you want to have over each individual train. A typical block length for the main line of the Apple Valley branch might be 6 feet. Add an additional pair of wires for each additional engine that you want to run. This is the wiring diagram for the Apple Valley branch. We have 3 pairs of feeder wires going to the main wires under the layout. We will refer to these main wires as our main bus. How many pairs of feeder wires there are on a layout is an option. This number determines reliability and what is needed to assure a good supply of current. Notice that there are no switches for turning power on or off to the track. Again, this is an option. Turnouts that have uninsulated metal frogs will need to have gaps cut in the rails so that there is not a short circuit. Most pre-manufactured turnouts, such as those by Atlas, are already gapped. For additional reliability, when locomotives move through turnouts, connect a single-throw, double-pole switch between the main bus wires and the frog. Many switch machines are available that can route the correct frog polarity for you automatically as the turnout is thrown. The Caboose Industries ground throws on our layout will be supported by 1/8-inch wood blocks that bring them up to the same height as the track. A hole is drilled for routing power to the Atlas No. 6 turnouts. This new ground throw has a built-in switch for routing power. 2 of the brass wire contacts connect to the main bus and the center one connects to the frog. The plastic pin on the ground throw fits in a hole on the turnout throw rod. When set in place, use nails to secure the ground throw. Notice the contact on the ground throw as it moves back and forth, making contact with 2 of the brass wires at a time. Reverse loops and turntables obviously reverse a train, but definitely require reversing the power as well, whether with conventional wiring or command control. As the train enters a reverse loop, notice that the positive feed is on the bottom rail and the negative on the top rail. When it completes the loop, pandemonium breaks out and the train comes to an abrupt halt because the polarity is incorrect. This problem is usually solved by a reversing switch. One can easily be made by wiring a double-pole, double-throw switch as shown in the upper right corner. Simply cross-connect the opposite corners with short jumper wires. Connect the 2 power wires to a pair of contacts on one side of the switch, and the 2 wires going to the track to the middle contacts. Switches that are pre-wired to reverse the current are also available from Atlas. Command control systems use a power booster to supply the electricity to the rails. With the Digitrack system, another power booster can be connected to the reverse loop as an option. This booster will switch the current automatically as the train travels through the reverse loop. To hook up a Digitrack system, simply run 2 wires to a power supply from the left 2 connectors. The right 2 connectors are for the main bus wires. We use 12-gauge wire. Atlas feeder wires have rail joiners already attached. To connect the other end of a feeder wire to a bus wire, strip away a small portion of insulation. By cutting around the bus wire first, and then cutting between the first 2 cuts, the insulation easily peels away. Be very careful with that knife. Then, wrap the feeder wire around the bus wire and solder for a permanent connection. Insulate the joint with electrical tape or heat shrink tubing. Digitrax communicates with the various throttles and accessories through a system of telephone wires called LocoNet. The first throttle plugs in the white connector and it plugs into the booster. A.J. Ireland of Digitrax is an electrical engineer who is in charge of the technological aspects of their products. He will be taking us through step by step, showing us how to install decoders in locomotives, usually considered the most difficult aspect of command control. These are the decoders. They receive signals from the throttle via the booster and rails to control all aspects of train movement and accessories. Many decoders have plugs connecting the wires. This makes installation and replacement of plugs easier, as we shall see in a moment. This controller is actually two throttles in one, having the ability to run two trains independently of each other. In fact, other functions such as turning lights on or off, sound functions, and even throwing turnouts can all be done from the controller. This panel mounts on the front of the layout, providing a place to plug in several controllers. The Digitrax system uses modular phone plugs. The panel also accepts a DIN-type plug used by other manufacturers. The Apple Valley branch used two such panels, one on the front and one on the back, to provide walk-around capability. Status lights show that the track is receiving power and when communications are being transmitted through the system. The back of the panel connects to the layout. Wiring of the panel into the system is very easy, as 6-wire RJ12 modular phone lines are used between panels. There are phone jacks on each end of the panel, one for an incoming phone line and the other to connect to the next panel down the line. By using commercially available lines that are pre-wired to different lengths, the user has the confidence to know that that aspect of the wiring is already correct. There is no guesswork. 2 screw terminals on the back of the panel are for running 2 wires to the track. This is to provide the power for the status lights on the front of the panel and attached throttles. Decoders are rated by their amperage, or the maximum current needed to power a specific locomotive. The HO and N scale decoders both have a 1 amp rating for their maximum load, the primary difference being that the N scale decoder is smaller. There is no reason why an N scale decoder can't be used in an HO locomotive if it meets the current demand, and it's a better fit. To test a locomotive to determine how much current is used, we will use a conventional throttle that has an ammeter and a voltmeter. First, hook up a short section of track with 2 wires to the variable DC voltage output on the back of the throttle. Without having the engine on the track yet, set the throttle so that the voltage reads 12 volts. This is our measuring voltage and serves as a reference point when there is no load on the track. Very briefly, place the engine on the track and hold the motor. The ammeter shows 0.3 amps. We now have 8 volts on the track, or 33% less than 12 volts. Multiply this difference times the 0.3 amp reading for a 12 volt current reading of 0.5 amps. Now that the proper decoder has been determined, the next step is to test the decoder before installation. The throttle is plugged into the booster, and the track status light shows that there is power available at the booster output. The decoder test kit from Digitrax includes a 100 ohm resistor that is used to help protect the decoder in case something is not correctly connected. The resistor is inserted into either of the track outputs on the booster. Now the decoder will not be damaged by a wiring mistake. This is the decoder that we will be testing. The wires that we need are the orange and gray leads to check the motor output functions of the decoder. These wires are connected to the 2 test LED leads that will simulate a motor. Carefully lay the wires out so that the bare connections are not touching. Weigh them down with something or hold them in place with tape. Connect either the black or red wire to the resistor previously attached to the booster. And connect the other wire directly to the other booster output. We now need to assign this decoder to a throttle. The default decoder number is 3. Press the select button, dial to number 3, and press select again. One of the green LEDs should now be flashing to show that a decoder is selected and which throttle it is assigned to. This same procedure is used for assigning engines on the layout to the throttles. As the speed is increased, the LED gets brighter. The percentage of speed is shown on the throttle. As the speed decreases, the LED should become dimmer. The color of the LED changes between green and red as the direction is changed on the throttle. This decoder is the DH84 1-amp HO decoder. The manual for the decoder includes installation guidelines as well as programming information for more advanced users. Opening the book up to the wiring page shows an actual installation, that is, a wiring diagram for the decoder. Normally, with conventional wiring, track current is picked up by these wheels and travels down these wires to the motor. What we need to do is interrupt this track motor connection and run all of our power only to the decoder. The most critical part of any decoder installation is isolation of the motor brushes. These need to be fed only by 2 wires from the decoder, typically an orange and a gray wire. Atlas's U33C locomotive has been pre-wired to take the work out of decoder installation by taking advantage of the NMRA's recommended practices. The wiring harness is removed from the decoder and an adapter harness with what is referred to as an NMRA plug is connected. A dummy plug that allows the engine to operate in the conventional manner is removed, and the NMRA plug along with the decoder is installed. Compress the wires so that they are not in the way. The shell is carefully replaced so as to not bind or catch any wires with the shell. This completes our installation of a decoder. This dummy plug should be retained in case you ever need to uninstall a decoder. These wiring harnesses are the wave of the future. The locomotive is now fully operational and ready to be tested. Oh, sure, we're going to show wiring other engines, but we wanted to show what the future holds as other locomotive manufacturers adapt their engines. AJ is now going to do a complete installation in a lifelike engine. This engine has a lot of room for a decoder and easily accessible wires. Begin by cutting the loco's red wire that carries power from the right rail to the motor. The red decoder wire is the wire that will be used to connect to the right side of the truck. The decoder will fit right on top of the weights and behind the light assembly inside the shell. The red decoder wire is cut to a shorter length and both wires are stripped. Heat shrink tubing is cut to a length long enough to cover the connection about to be made and placed on one of the wires before soldering. It is a good soldering practice to tin the wires with a little solder before joining them together. It helps to keep the wire strands together and prevents having to hold the soldering iron onto the connection for so long, possibly damaging components that might be nearby. Slide the heat shrink tubing over the connection and heat with the iron. This is much easier and more reliable than messing with electrical tape. To complete the connections for the right side, the orange wire is now cut to length and connected to the same place on the motor where the red wire was originally connected. Another method for melting the heat shrink tubing would be to use a heat gun that blows hot air like a hairdryer would. This might prevent accidentally touching wires with a soldering iron and melting insulation. The blue wire on this loco is providing power from the left rail or fireman side. This goes to the black wire from the decoder. The gray lead from the decoder goes to the remaining motor contact. This completes the installation of the decoder to supply power to the motor. All that remains is to connect the light and put everything back together. Go ahead and cut the yellow, green, and purple wires shorter, as these won't be used. Pull the insulation up so they can't short on anything. The ones that will be used are the white and blue wires. These are cut shorter, as were the others. The blue wire is the common wire for lights and other accessories, and the white wire is for the front headlight. This will be a directional connection, so that the light will only be on when the engine is set to go forward. When connecting light bulbs, it doesn't matter which bulb wire is connected to the white or blue decoder wire. Place the decoder on top of the weights and neatly bunch the wires around it, making sure no wires are near gears or drive shafts. Use a piece of tape to hold everything in place. This locomotive is now ready to be tested. It is a good idea, whenever possible, to test the decoder installation before putting the shell back on. First of all, it saves time. If something is wrong, you don't have to take it apart again. Second, if it works before putting it together and not after, chances are that something went wrong when putting it together. This is especially true with brass models that have a good chance of having short circuits. Our next installation is from Walther's line of diesel locomotives. This is an SW1, a very early model switcher that saw a lot of service on many roads. The shell easily comes off by lifting up on the cab and then the hood. Begin by tracing the various wires in the engine. The plate on top is used to route power to the top motor contact and the headlight. Remove the screws and pull the plate out, being careful not to catch any wires and pull them loose. Attached to this top plate is a metal strip that acts like a spring and pushes down on the top motor brush contact. This is a contact that we'll have to break. These black wires are the power wires coming from the wheels. Inspect the bottom of the motor by lifting up on it. Here we see that the bottom brush contact touches a similar spring that is mounted to the frame. We have to make sure that this brush doesn't touch the frame. By carefully clipping off some plastic sleeving at the end of the decoder, it might fit. And sure enough, it does. Just be sure and not damage any components when cutting the sleeving. The wires will be routed along the top of the motor. Another possibility would have been to use an N-scale decoder, but the HO decoder does offer the advantages of having a plug and another optional function output. These wires come from the front truck, and these wires come from the rear truck. They're joined on a PC board here. This wire and this wire both come from the right rail, which is toward AJ. The other pair comes from the left side or towards you. The right set feeds the spring on the top of the motor and also runs forward to the lamp. This set coming from the left side connects to the frame and goes to the bottom of the motor. So, for quick installation, these top contacts will now feed the decoder, the motor contacts will come directly from the decoder, and we'll break the light circuit out separately. Start by cutting 2 traces on the PC board that go to the light connections. Use a sharp knife and cut the gaps through the copper foil so that this part of the board is completely isolated from the rear of the board. We also need to isolate the left track feed by cutting a third gap slightly behind the second one. Solder the black decoder lead to the left contact at the rear of the PC board, and the red wire to the right contact. Tin the wire which will go to the top motor contact. When tinning the brush contact on the motor, be very careful when touching the soldering iron to the contact. You want to do the tinning as quickly as possible so as to not damage the plastic that is holding the brush in place. Because the wire has been tinned, it is now possible to make the connection very quickly. Cut the top spring contact off and bend it out of the way. Make sure that the contact can no longer touch the motor. The bottom motor contact that has been touching the frame is now straightened and the excess cut off. This contact can now be soldered to the gray wire. Place a piece of tape over the contact on the frame to prevent any contact with the motor. The motor can now be reinstalled. Be sure and put the drive shaft back on the gear coupling, and be sure that no wires are in the way. The metal plate is reinstalled with the original screws, if they haven't been lost in the carpet. The blue wire is connected to one side of the lighting PC board contact. This locomotive does not have a rear light. In this case, we are connecting both the white and yellow decoder wires to the other lighting contact. This will keep the headlight on, whether the engine is going forward or in reverse. Here's a little better view of the cuts that were made in the copper foil to isolate the various connections that have been made to this PC board. The hood can now be replaced, again making sure wires are not getting in the way. The decoder is now placed inside the cab along with the wires, and the cab snapped back into place on the frame. This completes our installation in a Walthers SW1. The next installation will be in a lifelike Proto 2000 FA2. By lifting the weight off, we can see the motor and the existing wiring circuit. This is the lighting assembly under a plastic shell. For this assembly, we will be using an N-scale decoder. We could install an HO decoder right behind the cab, but it would be a little long and necessitate having to cut away the firewall at the rear of the cab or cut some of the weight. Remove the plastic shell over the lighting circuit by prying up with a screwdriver. Don't worry about damaging this piece, as it will not be needed. What we find underneath is a bunch of diodes used for constant lighting. This means that this is a 1.5 volt lamp in this locomotive. These wires are coming from the trucks and are joined just forward of the motor. These are from the left side of the engine and provide power to the top of the motor. This red wire only connects to the lower contact on the motor and will now be connected to the orange wire on the decoder. Now that the lighting circuit has been removed, we can test fit the N-scale decoder. The first connection made is the black wire to the left feeds coming from the trucks. The red wire will be connected to the frame. Go ahead and cut the wires going to the diodes and remove them. The blue wire is connected to the frame of the locomotive. It's also the right-hand track feed. We're also going to connect one side of a 12-volt lamp from Radio Shack to the blue wire. The other side of the lamp will be connected to the white and yellow decoder wires. To prevent possible damage to the motor brush, the contact on the top can be easily removed for soldering. The gray wire can now be safely soldered to this contact. In this case, the heat here didn't melt the plastic brush holder. The orange wire is now soldered to the red wire leading to the bottom motor brush. Well, don't forget the heat shrink tubing to prevent unwanted contacts and short circuits. A short circuit could instantly send a decoder to decoder heaven. Fortunately, they can be returned to the manufacturer for repair. The green wire is again a spare. Put everything back together and tape down the decoder and wires to keep everything neat. This Proto 2000 FA2 is now ready for testing. The final locomotive for conversion is a Kato NW2. This will be our trickiest installation. First, remove the fuel tank from the bottom. Then, remove the metal truck contacts from each side. Be very careful with these and don't bend them. Now we have to spread the shell away from the frame to remove it. One method to do this is by using toothpicks to keep the different sections of the shell separated as it's pried away. This is probably the toughest part of this installation. These shells are very well secured, and it will take some effort to get them off carefully. As you work the shell off, you will see that the whole inside of the engine is frame and motor. We can now see that these points on the frame and inside the shell are what was holding it in place. New frames will soon be available from third-party manufacturers that provide a space inside the frame for the decoder. But since we don't have one of these new frames yet, let's start by removing the frame from around the motor. It's simply held by 2 screws and nuts. Two clips, one on each end, that are used to hold the couplers in place also need to be removed. The 2 frame halves are insulated from each other. That is a lot of motor. The spring contact showing is the track contact for the right side of the engine and provides power to the bottom motor brush. The orange wire from the decoder will be connected here. The top contact here goes to the left-hand frame half and will be connected to the gray wire. It is common for motors from Kato to have a white spot shown here that indicates the top side of the motor. We'll place this decoder in the cab, so separate the cab from the hood. This will be another N-scale decoder installation because it is a better fit inside the cab. Similar to the Walther's engine, the easiest way to make the decoder connection is to the existing PC board used by Kato's conventional wiring. The black wire will be connected to this point here, and the right-hand side red wire will be connected to this point. Remove the motor completely from the frame, keeping track of the gears and bushings as you go. Notice there are little couplers inset into the flywheels. Go ahead and remove them and set them aside so they don't fall out unexpectedly. The caps holding the brushes are pulled out so that we can again solder the decoder wires without damaging the brushes. The tab will be cut back as it will not be needed, leaving only enough for a solder connection. The usual connections are made with the gray and orange wires going to the motor. Keep track of the white dot as that indicates the top of the motor and the right-hand track feed. The flat part of the brush goes into the motor first, and this is the spring end. This is what the finished motor connection looks like. As in previous installations, place a piece of tape over the connections to remove any chance of a problem. Place the motor back in the frame and check that it is properly seated. Everything should line up perfectly. When placing the other half in place, be sure that the notches for the gears and bushings all line up. We must again cut a PC board trace to isolate the track pickup from the headlight. This contact is shared with the headlight and the right-hand track pickup. The decoder wires for track power have been soldered to the rear of the board, and the white wire is soldered to the right front of the board. The frame can now be reassembled and the trucks inserted while the frame is still loose. Place the hood back on the frame and feed the decoder up through the opening to the cab. The rear light is connected to two contacts that are inside the cab. The left side of the engine will continue to make contact, and the right side will be folded up and connected to the yellow wire. This will take advantage of the system's built-in directional lighting capability. Fold everything up and into the cab, then snap into place. This will look better without the decoder in the cab, with the new frames made specifically for decoders becoming available. Now, we can't test this one quite yet. Insert the truck contacts back into place so that each end is resting on the top of the truck's contacts. The fuel tank holds these in place. And now we're ready for testing our Kato NW2. Our thanks to AJ for his many seconds spent installing these decoders and making it look so easy.
Hi, my name is Paul Latour from Southern Digital, and today we're going to be doing a decoder installation on a Kato N-Scale C30 or a Kato U30-7 locomotive. It's basically the same locomotive on the inside. The only difference is the outside shell. Okay, we're going to disassemble our locomotive now. What you do is you grab your N-Scale locomotive by the fuel tank with your left hand, and then wiggle the chassis with your right hand. The rear of the locomotive will come up. Slide it forward a little bit because it kind of latches in place, and set it aside. And your shell is removed. Remove the fuel tank by snapping it off. It just simply snaps in place. You may need a little screwdriver to help it. Okay, set it aside. Next thing we're going to do is remove our connection buses, or copper buses that hook the trucks to the side frames. Use the tweezers and pop them off. Okay. Then we'll remove the shroud that goes over the front headlamp to keep the light from shining out the cab windows, and simply slide the light bars out of the frame. Set them aside. We're going to reuse all of these parts when we put the locomotive back together. Now, the two frame halves, as you can see, are held together by Phillips head screw at the front and the rear of the locomotive. Remove the screws. The nuts will fall out the back side, and then the trucks will come out and the frame halves will be able to be separated. Before you separate it, so you don't lose all the parts, set it back down in your work area, and then the frame halves are held together by 4 clips, and you can release those by pressing them towards the center or simply just pry it apart, and that will release the motor and the motor cage from the inside of the locomotive. And there you have it. There's all your running gear on the inside. You have your bearings and your worm gear, your motor cage around it, both at both ends. And then you have 2 insulated spacers that keep the 2 halves electrically isolated. Remove those from your frame. Set those aside. We're going to reuse those. This frame half is void of all parts, so set it aside. Simply pick your worm gear and bearings up, set them out. Try and not lose the front bearing because that will come right off. Okay? Then we pop our motor out. So now we have an empty motor shell. Now before you change the orientation on the motor, it's important you make note of which is the top brush and which is the bottom brush cap. Kato marks the top of the motor with a white stripe, so you know this is the top of the motor, so when you're doing your wiring you'll be able to wire it accordingly. Okay, set that aside. Now the motor cage simply pops off of the motor, and this is what suspends the motor inside of the chassis. Okay, you have 2 choices with your frame. You can machine an area out to take the decoder, cut all the slots. It's not an easy task. Or you can buy a replacement chassis or replacement frame. At Digiframes we make a replacement chassis for the C30, U30 N-scale locomotives that have taken out all of the excess material that's not necessary, so that you can slip the decoder inside of here and the shell will fit back on. Okay, here's the replacement frame. As you can see, we've machined out an area in the fuel tank to accept the decoder. By doing that, we don't eliminate any of the lamp bars that originally came with the locomotive, so you don't have to specially wire in a light. Take the frame halves and separate them. What we're going to do is we're going to start with the side that has the retainer bars. Now the retainer bars are only on one side of the frame. As you can see, the other side does not have the retainer bar. And those retainer bars are directly adjacent to the motor cage. If you notice the motor cage, there is no retainer bar on one side, but there is on the other. So when the motor goes back in, you'll put the retainer bar on the cage upwards because it has another one on the bottom side. Okay? Now we've already pre-cut our wires. With your replacement chassis, it gives you instructions on how long to cut each one of the wires. I pre-cut the wires so that I don't have a lot of excess wire to contend with while I'm putting the locomotive together. Now, our gray wire is our long wire. That will be the top wire. Our orange wire is the bottom wire. Now that we have the wires soldered in place, we're going to slide our motor cage back on top. So we want to take our wires, lay them underneath the motor, and slide motor, wires, and everything into place. And we want to try and keep the wires parallel with each other when they pass through behind the motor. Okay? Now that we have our motors in place and our decoder basically in place, we're not going to stuff it in the area yet, not till we've got everything back in its proper order. We're going to replace our bearings and our gear mechanism right now. There's a hex nut on the end of the shaft that goes into a hex on the flywheel. So we slide the hex nut inside of the flywheel and set our bearings back in the bearing blocks or bearing bushings here. Do that for both the front and the rear drivetrain. You want to make note of the bearings themselves on the front of the gear train. They do come off. If the bearing does come off of the gear train, your front bearing, you want to make sure it goes back on properly because there is usually the residue of the spew when they cut this plastic bearing off at the manufacturer. If you put this bearing around the wrong way, that spew will hit this gear and it'll cause a clicking. So either clean that off and or make sure it's towards the ends of the locomotive, and you won't have that problem, that extra noise. Okay, we've got our gear train back in place. Now we want to replace our insulators. Okay. Then we mount the second half of our frame back together again. Snap the motor cage holders in place. Okay, with everything in place, screw back in. Don't seat it. Okay, on the trucks, on this C30 or U30 locomotive, you want to make note of the center post or the pivot post of the truck. It is not in the center of the truck itself. It's off center. In this particular locomotive, the long side, this side, goes towards the fuel tank. The short end goes towards the couplers. It won't fit in the other way around. So you want to make that note. Take that coupler unit, and now that you don't have this tight, you just set the truck in place for both the front and the rear. Leave it upside down, and then tighten your screws. Now the trucks are secure in place. Okay? Okay, next thing we're going to do is we're going to make sure that everything is free on the inside. So go ahead and spin your flywheel to make sure your motor and your gear train spins free before we do anything else. If it doesn't spin free, take it apart and make sure you get rid of all the binding. Okay, slide the decoder into the fuel tank area. And then what we're going to do is come over here and check the wires on the other side to make sure that they're nice and parallel. They're not binding in the motor. There are tabs here on the side of the frame. The way the bus bar goes back in, the U area obviously goes through here, it comes out, and then the bus bar goes underneath this tab so it has tension to touch the power pickup on the trucks. So that's your task, is get that in at this end and underneath the tab at this end and to touch the trucks. Okay. Okay. Side one is in. Can you see that all right? Okay, now we go around and do the other side. Now you have to be real careful because those will fall out of there quite easy. The only thing that holds it in is when we snap the fuel tank back in place, and the fuel tank will hold these copper bus bars in place. So while you're putting them back in, be careful. Okay, hold the bus bars in place with my thumb and forefinger, and then snap the fuel tank back in place. There we have it. The black lead is going to go to this area. The white lead, which is your front headlamp, goes to this area here. Your red lead that picks up from the other side of the frame goes here. And then the green lead we're not going to use because that's an additional function lead we're not going to use in this installation. Okay. Then all we need to do is solder one wire to the rear lamp, and that's the yellow wire. Had a little bit too much wire showing, so you want to cut your excess off. Solder your wire in place. Dress it down. Okay. Last thing we're going to replace is the front headlamp shroud. Okay. These two clips on the bottom of the headlamp shroud slide into two slots inside of the frame here. What we do is turn this thing upside down and slide him in place, and he'll snap right into place like that. And this shroud simply keeps the front headlamp from coming out the windows of the cab, so that the light only comes out from the headlight on top. Okay, the next thing you want to do after you've got the headlamp shroud on, before you put on the cover or the shell of the locomotive, take it over to your test track, test it, program it, set your addresses, make sure you put it in the advanced mode so you can turn your headlights on and off, and then run it. Make sure it runs properly. Then come back and put your shell back on.
Hi, my name is Norm Stenzel. We're going to install a decoder in an HO locomotive. We're going to install one in a brass steam engine, which is probably the scariest installation for most people. The first step will be disassembling the locomotive. Most brass steam engines come apart the same way, usually held together with 3 screws. First one is generally right in the middle of the cylinders. This particular one also holds, that same screw holds the pilot truck on. It'll come off as an assembly. Okay, after you take out the front screw, there's usually 2 in the back of the cab that go into the frame. Just take those out. Just let them, make sure you have something underneath to catch them when they drop. And I generally have a little container off to the side here to keep the screws in so I don't lose them. And gently just lift the superstructure off, and you have your chassis. Second, we'll disassemble the tender. This particular one's held together with 4 screws in through the floor. One more thing that you'll take apart is usually the smoke box cover. Just snaps in. This engine, I've already made some modifications to it for my own railroad. I've added an awful lot of weight to the locomotive, so there is no place in the main superstructure to mount the decoder. So we're going to put the decoder in the tender, and this will require a plug and a number of wires running between the tender and the locomotive. Since they're all different, I'll just tell you what I do, or what I did on this one. I've already drilled an 1/8" hole through the headlight and through the front cover of the boiler. This gives me a place to stick the light bulb in. On the tender, this particular locomotive didn't have a rear headlight. Since all mine do, I've added a cal scale headlight to the back of the tender, and it's drilled vertically from underneath, so the bulb will come up from the bottom. This is a 12-volt bulb, little mini bulb. Usually twist the wires. When I install the headlights, I use a handy little product that I discovered in my line of work. This is air conditioning insulating tape, and I'm not really sure what it's made out of, but it's very sticky, very moldable. And I don't know if you can see that, but I just took a very small piece, rolled it up, and I'm going to wrap that around the base of the headlight bulb, and this will hold the bulb in the headlight assembly. Just roll it between your fingers. Get about the size of the hole. Like that. I paint the inside of the headlight silver, because once the bulb is in there, it's in there, and it's very hard to paint. Just pull it back into the headlight and just push it in. Get it back far enough so that when you put the lens in, it clears the bulb. Let me stick this one in from the bottom. Like I said earlier, I've got so much weight put in the boiler of this one that there is no place in this locomotive that the decoder will fit. So we're going to mount it in the tender. And to do that, I'm going to put a plug in the base of the tender. It'll take 5 wires from the decoder to the locomotive to handle the headlights, motor, and pickup from the track. To make that plug, what I use is I go to my got a local electronics store, and they sell these headers which are used in printed circuit boards. These are great to make plugs out of. You figure out how many wires you're going to need. We're going to need 5. So I'll cut off the end of this thing for 6, and then what I do is I key the plug. I'll cut off one pin and fill one of the holes so that you'll only be able to plug it in the right way. You won't be able to plug it in backwards. I know it's brass, but we're going to have to do some cutting on it. Wait, I'm just using this for a measurement. Let me mark it. You're not going to be able to see this, but I'm just going to scribe a line so I know where to cut it. I'm going to remove this part of the tender, and then we'll attach the plug right here with ACC. Believe me, it's not alive. It feels no pain. I'm also going to cut this mounting strip out of the way so that it clears the plug. Do this very slowly, just a little bit at a time, because when you're cutting it, you're also getting it hot, and things have a bad habit of coming unsoldered if you get them too hot. So just a little bit at a time. Now on most brass engines, they pick up one rail in the locomotive and the other rail in the tender. So one of these will just get soldered to the tender. It'll be the red one. And one of these will go, the yellow one will go to the rear headlight, and that'll get soldered directly to the bulb. These other 5 wires have to go through the plug. And I found it's a lot easier to solder these to the plug before we install it in the tender. Okay, I'm going to make a little drawing for my own benefit with the 6 ports on the plug here, on the, actually it's socket. And I'm just going to label what wires are going to go where. It's going to be orange, blue, white. These particular plugs are made to crimp on the wires. I'm still going to solder them, but this makes soldering them a whole lot easier because you can have them all preset. I don't know if you can see how the wires just fit in these little forks. Go in and nip the ends off. Nothing to it. There be the plug. Now the yellow wire is the reverse headlight. And you're going to want to hook your two light leads, one to the yellow lead and one to this blue lead that we hooked on the plug, and we'll solder it right to the plug where we soldered the other one, as good a place as any. Get rid of some of the excess wire. Twist the 2 leads together. Now solder them. This is especially important when you're working on a brass engine, because anything in that brass engine it can touch is a potential short. Cut off a length of double-sided tape. Attach this to the bottom of the decoder. Peel it off. Find a flat surface in the tender and just stick it in there. A little ACC. Just put a little puddle right there. Doesn't take much. And I've been mounting these plugs like this for about 10 years and I have yet to break one loose. Get it in there straight and just hold it till the glue sets. Alright, one last thing we have to do is solder this red wire to the tender. Okay, most brass engines, this one in particular, come with either a clear or they're actually painted. They've got a protective coat on them, so if you're going to solder to them, you got to come in with your file, actually clean off the surface where you're going to solder. There we go. That's the complete installation in the tender. And you can see where the plug is. Okay, and pull it through. And then take your boiler front. Get it in the right place. And snap it back in place. And what I'm going to do here to make it a little bit easier to handle, so I'm going to put a little plug on the headlight wires so that I can unplug it from the chassis and work on the chassis separate. I'm going to use the same thing that we used for the plug in the back, only in this case I just cut off 2 pins and made a much smaller plug. Little dab and it's done. The next thing I'm going to do is I'm going to make up our harness. I'm going to use one of the wires we cut off the decoder. This will carry the track voltage from the chassis side. And then I use this fine hookup wire that Walters sells for the motor leads and for the headlight leads. I'll use 2 different colors just to make it easier on myself when it comes to soldering it. Take each of these leads, fold them double. Same with the red one. These together. Add your heavy wire and just twist the whole mess together. Into a cable. You'll take your clippers and you just cut it off across the end. Now you've got 5 leads to solder to your plug. One down, 4 to go. You have to kind of plan ahead which way you're going to run your cable. This one's going to have to go down. It's going to loop around and come back up into the locomotive. like an umbilical cord. Okay, your green leads are going to go to the motor, so we'll cut those off right here. At this point, I leave them the same length because, to be honest, I have no idea whether this locomotive is going to go forward or backward when we wire it. We got a 50-50 chance of being right. The red leads are for the headlight, and they're going to come up here to about where the gearbox is, because that's where we're going to mount the plug. This could also be soldered directly to the frame or any other part of the locomotive you found accessible. Try not to glue my fingers to it. As a finishing touch, once I've determined that the plug fits and everything is where I want it, so I take latex rubber, just dab some on the end of a toothpick, and just ladle it into the plug here. This both insulates and protects the connections. And eventually, when you paint the locomotive, you paint this plug black. And it gives it a much more professional look to it. Like that. That'll dry in about 15-20 minutes. And you've got a permanent plug. And there's the finished product.
The Apple Valley branch has hidden tracks that are impossible to see from the front of the layout. Because command control has the advantage of being able to run many trains on the same track, we need to know from the front of the layout what trains are occupying these hidden tracks. Circuitron has a block detection system that is easy to install. One package has 4 photocells that are sensitive to light. Simply drill a hole between 2 ties big enough for the leads and drop into place. One common wire goes to all photocells. Additional wires go from each photocell to the supplied circuit board. The top of the circuit board has a connection for each of the photocells and the common wire. The bottom connections are for lights or LEDs on the control panel at the front of the layout. Power is supplied to the left side of the board. There are 4 thumb wheels on the corners, one for each photocell. Once everything is hooked up, simply rotate the wheel until the light comes on, then rotate back until it just goes off. The control panel has a schematic of the hidden tracks. We used LEDs from Radio Shack for the lights. Six detectors were spaced evenly along the 10-foot length of the layout. The wiring for the Apple Valley branch is fairly simple. Command control takes most of the work out of that. The bigger challenge is getting decoders into tight places. Having 5 examples of decoder installations on this tape, future engine frames designed for decoders, engines pre-wired for decoders, and your own experience will make each locomotive easier and easier. It's very plain and simple. Structures make a layout come alive. They add that sense of realism to any layout, especially structures that are well done. Structures come in all shapes and sizes, even a swing and teeter-totter in a park. In this tape, we'll concentrate on different structures that offer variety, usefulness, and believability to your layout. Bridges are structures too, and this tape will help you construct and place a bridge. Since we're modeling a part of the country that also grows grains of different types, we'll also build a grain storage facility. Your local hobby shop probably carries a variety of good kits. We like those kits supplied by Walthers, Atlas, Plastruct, BH Models, and City Classics. They are reasonably simple to build and realistic in appearance. The Walthers Cornerstone series are some of the finest looking kits available and are easy to assemble. We'll even take you through some reasonably difficult construction of ladder assemblies on the granary. This project will help you understand that no matter how difficult a kit may look, by breaking the kit down into sub-assemblies, the construction is relatively easy. We'll start our first project by showing the assembly of Walthers' grain dryer. We suggest that you lay out the parts to be sure all parts are in the kit, and in that way you'll become familiar with the part names and shapes. Some parts will have to be removed from the sprues, so placing and identifying those parts now will save construction time later. We'll start out by assembling the metal supports which attach to the base. These supports must be square so they'll fit on the base. Before we add the last side to the supports, we test fit them to the base. We can always adjust the last piece of the support so it fits the base. Doing this will assure a good fit to the base. Now we can fit the last piece of the support section. We use plastic weld liquid cement made by Plastruct to glue the parts together. Touching the parts at the joint will allow the cement to be pulled into the joint by capillary action. We next assemble the ends to the top part of the dryer. We place plastic weld on the side piece near the ridge used to guide the top piece in place. Then, we place the top piece in position and add some more cement to the joint. Next, attach the other end piece in the same manner. The top of the dryer is attached next. It will take a little time to fit the part in the proper position. We cement the top part of the dryer in the same way we attached the other parts. We used rubber bands to hold the assembly together until the plastic cement sets. The vents in the dryer will look more prototypical if they're painted. We used black paint for this. Now the entire dryer assembly can be fastened to the support section we made earlier. And finally, the concrete base can be added. We pre-painted the remaining parts to be attached to the dryer as per the instructions in the kit. Now, we cut off one of those parts with a knife. We touch up the edges of the part where the sprue was attached, using a thinned mixture of the same paint color. Now we attach the part to the top of the dryer assembly. The various sections we built as sub-assemblies now make up the complete dryer. The tower between the grain elevator storage bins is our next project. This BH model kit is built up with angled pieces which are joined together to make a box. These boxes are then joined together to make the tower. The fan assembly or distributor head at the top of the tower is built up from a number of pieces. Here we see the motor, the sections where the feed pipes will be attached, a funnel, and the motor mounting platform. Once assembled, the funnel must be secured with a piece of wire. We drill out the funnel with a drill the size of the wire. Then we place some ACC cement on the wire and insert it into the hole. Here's the assembly with all the parts attached. Note the motor and the fan assembly with the funnel and pipe feeders at the bottom. The assembly of the platforms is next. These include the railings and bases for each platform. We first assemble the base and then cement the railings to the base. Clean up the railings to remove any sprue cutoffs. We used an emery board. Then cement the railings to the base. It's easier to cement the railings to each base section before cementing the base sections together. Finally, cement on the shorter end railings. Next, we'll attach the platforms to the tower. They should slide snugly onto the tower and should be cemented in place. The ladder brackets should be attached next. The instructions show where these should be attached between the platforms. We place them in position and carefully flow some cement into the joint. When the cement holding the brackets is set, slide the ladder down through the platforms and the brackets. Next, add the handrails and cement these in place. The time spent in carefully assembling the tower now pays off, as we have a really fine-looking assembly. The grain silos by BH Models are next. We'll need a sharp X-Acto knife and some fine sandpaper, as well as some ACC superglue to assemble the silo parts. The bands of the tanks are all separate, and the round silo is formed by gluing the pieces end to end. But first, the edges must be cleaned up to remove any flash. This is where the sharp X-Acto knife comes in handy. Always cut away from your hand, never toward a finger or hand when you trim small parts such as these. Now, smooth out the edge with the fine sandpaper. Continue this trimming and sanding operation on all of the bands. Next, place a small drop of superglue on a band and hand clamp the next band to it, as we did here. Continue adding bands until the circle is complete. It's very easy to add an additional section to increase the diameter of the silo. After the bands are complete, it's time for assembly of the sections to form the silo. The vertical tabs should be offset from each other to give the silo rigidity. When we reach the top of the silo, we want to remove the protruding tabs so the roof will fit on top. We remove the tabs with a cutoff tool available at Radio Shack. Make sure the top of the silo is smooth and flat, and then add the roof cap. It should snap in place. You can purchase additional bands to enlarge the diameter or height of the silo. We'll use Plastruct part TB-16, cut 12 scale feet long to make up a propane tank. Then we insert the end pieces and glue them in place. Next, we glue on the filler vent piece to the tank. This part is called a stub-end T. Finally, we cap the T with another clear dome piece. The two tanks and the Walther's dryer are now ready for some connecting piping. We'll use Plastruct's piping, which is easily bendable. We measure the distance needed for each bend, use a pliers to bend the piping, and continue our bends until the pipe is formed, as shown here. Then we cut off the piping with our nippers. T's are easily added with Plastruct material, which snap onto the piping. Cement will fix them in place. We also cut another pipe for our second propane tank and attach it to the T. We'll need valves for the piping, and they snap onto the piping as well. Glue the assembly together and you're ready to attach the piping assembly to the dryer and tanks. Next, we'll provide some tips to build the Walthers cannery. We used a rubber band to hold together the two pieces of the roof-mounted water tank. Next, we use a triangular file to smooth the joint where the two sections meet. To assure that the tank frame is square, we placed one side on some masking tape laid sticky side up, and the mating piece against a square board also held to the masking tape. We glue the other side in the same manner. The three sides are now assembled and square. The part is ready for painting and mounting to the tank platform. Place the platform upside down on a flat surface and position the brackets. Then apply plastic cement to the joints of the two sections. The walls of the cannery need to be painted a flat, dull brick color. We use a medium brown color. Then we mask off the walls so we can paint the columns. We use a low-tack masking tape that will allow us to mask within an hour after painting the walls. Placing the mortar between the bricks is the next step. We use a water-based white poster paint. We thin the paint to the consistency of a milkshake and liberally brush it into the mortar lines. Make sure you get all the mortar lines filled with the paint. Next, we rub the paint off the tops of the bricks. We dip the end of an old t-shirt into some alcohol to help remove the water-based paint. We constantly change the t-shirt position to assure a clean spot on the shirt. We weather the roof with an airbrush and some grimy black paint. We lightly spray the paint using vertical streaks to simulate water and grime running down the roof. Now we'll show you some tips we came up with in building Plastruc's water tank. This tank is from their Trackside series of kits. We must scribe the horizontal lines in the tank, which simulate the separate sheeting the real tank was built from. We measure the tank and find that it's 2 inches high, and we want to scribe a line right around the middle or 1 inch from the top or bottom. To get those lines even all the way around the cylindrical tank, we purchased a hose clamp from an auto parts store. When the clamp is placed on our 1 inch mark and tightened, we can use one edge of the clamp as a straight edge. We'll scribe that edge with our X-Acto knife. To simulate the vertical lines, we hold our steel straight edge on the tank and again use our X-Acto knife to scribe the line. A flat mill file with serrations running in both directions is one of 3 files we'll use to smooth down the plastic parts. We used a smaller and finer file of the same type for smoother filing. And finally, we use a very fine file with serrations running in only one direction. Files like these are available in most good hobby shops or from Micromart. We use MEK to glue our plastic parts together. It's available from most hardware stores. The solvent is toxic to breathe and flammable and should be used in a well-ventilated area. We also use a vernier caliper to measure diameters or thicknesses of material. This one measures in 1/1000th of an inch and in HO scale. In our case, we must drill a hole in the top dome of the tank. The hole must be the same diameter as the dome cap piece, and we use the caliper to measure the dome cap piece diameter. Then, we look on our scale rule where translations from 1/1000th of an inch to drill sizes are given to come up with the right drill size. Our measurement was 0.092, and the ruler states that this is a 3/32 inch drill. We pick out a 3/32 inch drill from our drill collection, drill the hole, and test fit the dome cap into the hole. The fit is perfect. Next, we dab some MEK into the joint to securely weld the two parts together. The framework under the tank is a bit more difficult to build, so construct it on the plans like the airplane modelers do with their stick-built planes. We tack some wax paper over the plans and use straight pins to hold the tubular pieces in the correct position. Next, we cut and then glue the diagonal cross pieces in place, holding those with pins where necessary. We tape the edges of the finished section to a cutting pad which has squares drawn on it. We use these squares to help align the sections. We brace each side with some 90-degree squares. Then, we glue the horizontal cross sections between each side assembly. Walther's Cornerstone series includes a block of buildings called Merchants Row. These buildings offer the model railroader a fine assortment of typical small-town buildings. To individualize the appearance of each building within the block, they need to be painted different colors, just as they are in real life. We painted this section a medium dark green color, while the section was still on the sprue. The sprue serves as a good handle while painting. We mask off the areas we don't want painted and use paper towels to speed up the coverage of the unpainted areas. Then we spray on the next color. Remove the tape once it is set and continue masking any other areas you want to paint a different color. We've noted that these old buildings usually are painted the same color on the sides as the front of the corner building is painted, so we painted ours in like manner. Here we're painting the front of the building the same color, so it will match the side color we just painted. Now, remove the masking tape. We next will paint the door and window parts with trim colors. We start with a green color for one part of the building. Use a small brush to gently paint the inside and outside trim around windows and doors. Lay the brush flat when painting the flat portions of the windows, and the paint won't run onto the brick parts. If you've taken your time and a few breaks between windows, you should have a very realistic trim color neatly applied. We use a brown color for door trim, applying it in the same manner as we painted the windows. We did not try to paint inside the edge of the door, as the paint would run into the brick mortar. Next, use white paint for the brick mortar. Just slop it on with a large brush, taking care not to get it on the inside edges of our window or door frames. Wipe off the paint before it sets using a Kleenex or an old rag. Dip the rag into some alcohol if the paint is a little difficult to remove. We want to take the paint off the top of the bricks, but not out of the mortar lines. Continue with each section of the building, painting and then removing the paint off the tops of the brick before it sets. The windows need to be glued in place. Dab a small drop of superglue on each corner of a window, and then carefully place the glass over the openings. Don't slide the glass into place, but rather drop it gently onto the frame. Place two of the building sides on a flat surface. We used a sheet of plate glass. Use a medium brush to apply the plastic weld cement to the inside corners. Hold in place until the cement sets, and let stand for a few minutes before working on another wall. Check the corner for squareness. Continue around the building, adding and cementing the corners of the walls. Keep checking for squareness. When the cement is set enough to hold the walls securely, test fit the roof between the walls. It should drop into place with only a small amount of pressure. Central Valley offers a fine plate-through girder bridge. We'll take you through some of the more difficult steps to assist you in its construction. The bridge comes as a through girder type. We converted our bridge to a deck girder type because our bridge was on a curve, and the long tank cars of our railroad would not clear a bridge with side girders on it. We will have to remove some detail on the bridge base to accommodate our moving the side girders from the top to the bottom. The first detail we'll remove is the rivets in the corners. We'll be mounting our bridge shoes here. We will also have to remove some detail on the side girders to allow the cross members to be glued to a flat surface. Use a chisel-shaped blade to carefully remove the detail. The chisel-shaped blade is also used to remove the material near the end of the bridge. Use a file to smooth the area where you chiseled off the material. The bracing on the top, or in our case the bottom part of the bridge, should be applied next. This bracing stiffens the plate in real life as well as on our model. We used plastic weld to cement this in place. The triangular braces will go here, between the side plate girders and the main floor structure. We hold the floor structure in a vertical position and against one of the side girders while we apply plastic weld cement to the joint. Next, we cement the triangular gusset plates to the two parts. Well, that's it. We've taken you through some major steps in building structures, and you should have your own town, bridges, and cannery complete in no time. Your layout will look much more realistic with well-built and weathered structures in place, and the joy of operating your layout will be enhanced by these fine structures. Rolling stock, or freight cars, are the lifeblood of the railroad. They're the reason for the railroad's existence, to move freight. This tape will not only show how to assemble a basic freight car, but also how to have cars that operate smoothly and with each other as a train. First, we'll show you how to build a plastic boxcar kit. Then we'll cover the fine art of weathering a car with paint. And we'll also cover how rust and other dirt can be added to cars. A hopper car will be completely changed from one paint scheme to another. And you'll learn how we improve performance by changing trucks and couplers. Walther's standard 40-foot boxcar kit will serve as an excellent example of how a basic boxcar kit can be constructed. The plans describe how the kit can be made to look like a car from 3 different eras. The instructions are very helpful and should be read thoroughly before starting construction. The exploded view is also an excellent guideline. We've laid out the basic parts of the kit so you can see what is involved. At the top is the body structure. Below the body is the center sill. Below that is the floor. And at the bottom are the car weights. To the left are parts that will be used for the brake gear. Also available in this kit are different doors and end castings, so you can choose the era of your boxcar. The first item to be tackled is to remove any flash from the floor casting. We used an X-Acto knife to remove that flash. Always cut away from your body or fingers with a sharp knife. Keep scraping with the knife until the parting line, left over from the molding process, is removed. This car has a section between the side doors which represents a scribed floor. The flash should also be removed from this piece. There are two notches in the floor section which fit between pegs in the floor. We used plastic weld plastic cement from Plastruck to hold our parts together. We brush a small amount on the mainframe floor, where our wood floor section will be placed. We also brush some cement on the bottom of our wood floor section. Then we snap the wood floor section in place and apply some mild pressure to the two parts to make sure they join properly. You'll want to hold the parts for a few seconds to assure yourself of a good bond. Next, we'll install the two weights that come with the car. These weights assure that the car weighs enough to track right on your layout. These must be held with a glue that will hold dissimilar materials. We use Walther's Glue, a long-time favorite glue modelers use for fastening unlike materials. First, we smear a small amount on the frame, where both weights will finally be set. Then we place the weights into their proper location, wait a few seconds, and lift them. Let the glue set for a minute or two, and replace the weights. They will stick forever. Katie's number 5 coupler is the right choice for this car. KD couplers are the accepted standard by the vast majority of model railroaders. We will use the coupler pocket covers that come with the kit to retain the couplers in place. We will cut them off the sprue with our nippers. Then clean off the flash from the cover to assure it fits in place snugly. Insert the centering spring mechanism supplied by KD. Then insert the coupler. Hold it in place and place the cover over the coupler pocket. Make sure the protruding square in the middle of the cover is facing toward the pocket. The last step is to screw the coupler assembly together using the screws provided in the kit. Make sure that the coupler is free to pivot, but not so loose that it dangles down when the car is in its normal upright position. We're now ready to install the main frame assembly to the underside of the car. Make sure you match the brake gear. The air tank should be directly opposite this hole on the main frame. Clothespins make a handy clamp. One is placed at each end in case one end tries to lift away from the floor. Then we use our plastic weld to cement the sections together. Now, add the remainder of the brake gear parts. We'll use our nippers to cut the sections off the sprue. As before, place cement on both parts to be joined. The brake cylinder assembly is next, and we cement this assembly in the same manner as the others. Now to assemble the trucks. The side frames come pre-assembled. All we need to do is snap the wheels in place by gently pulling the side frame apart and inserting the wheel. Make sure that the wheel turns freely. The boxcar came with the roof walk already in place. The tabs protruding into the underside need to be cemented to firmly attach the roof walk. Then install the doors. They slide into place, and then we snap in the upper door guides. Use some mild pressure to secure these in their respective holes. Check the doors to be sure that they move freely. The instructions call for removing the tabs on the bottom of the ends. We'll use the nippers to cut these off. Then, use a knife to trim off the flash left by our nippers. Finally, a file will smooth out the end. To assure a good fit of the car floor assembly into the box assembly, we must file the ends and sides of the floor assembly to remove any burrs or flash. Notice, we take long, bold strokes so we don't file too much in one place. Before snapping the two sections together, we must identify the brake wheel end and match it up to the proper end of the floor assembly. The brake cylinder points to the brake wheel side. Gently pull the sides apart and press the floor section into the box assembly. Then push down at each end to seat the floor assembly. Next, fasten the trucks to the frame. Notice we've placed the screw into the truck bolster before we lay the truck onto the frame. Drive the screw into the frame, but do not over-tighten. We want some sideways movement to allow the trucks to run over any slightly uneven trackage without derailing, but not so loose that they flop around like a fish out of water. Our car is complete. Or is it? It looks too new. So, how about making it look older with some weathering? There are several ways to weather a car. The first way we can weather a car is by dry brushing paint in appropriate places. We use Acuflex paint here. The color we chose is Milwaukee Orange to simulate rust. Take a small amount on the tip and wipe most of the paint off onto a paper towel or Kleenex. Then, lightly brush the paint on the ribs of the car. Here's where grime and eventually rust will collect. Look at the prototype to see where the rust and dirt are embedded. Work with light, vertical strokes. Remember, it's easier to apply too little and then come back and add more. Don't forget the trucks. Dirt, rust, and grime settle there too. You can use a larger brush where you want to apply the weathering to a broader surface. When complete, the car takes on a character of its own and looks like it's been in service for quite some time. Using a larger brush, fill in the rust and dirt between the ribs, brushing even lighter than before. Another method we like to use for weathering is weathering with pastel chalks. We chose 3 different colors as you see here. The colors you choose may be different. Again, we suggest you look at the prototype. We scrape off some chalk onto a piece of paper using an X-Acto knife. Then we lightly dab a soft brush into the chalk dust and lightly apply the chalk to the car. It doesn't look too great at the start, but we will continue to brush the car, working the chalk into the finish. Keep applying the chalk to weather the car to your taste. Some cars will be weathered much more heavily than others. Then we'll use black over our last color. Apply this to the roof to simulate soot from the steam or diesel engines. Now, tank cars require a little different weathering pattern. Since they're round, dirt and grime cling to the top more than the sides. We use our chalk dust to simulate the grime that would collect near the dome. Oil or chemicals spill near this point, and dirt and grime more easily collect on the residues of these chemicals. Don't forget the platform. This flat surface will also collect grime more readily. For weathering the handrails, we use a mixture of Acuflex's Western Pacific Orange and Milwaukee Brown. Dip the brush into one color and then the other, and brush it onto the handrails. This color mixture will simulate metal that's dirty and rusty. Make sure the brush is wet so the colors flow right on, and you'll get the effect you need. There's another good way to weather a car, and that's with an airbrush. We have 2 Badger airbrushes, which we use for different jobs. Filling each with a different color can save time. Badger's silent compressor is an excellent choice for providing a steady air supply without a lot of noise. Our model is equipped with a pressure gauge, a regulator, and you can connect your favorite airbrush with ease. Try your first airbrush weathering project on a less expensive car. Lifelike cars look great on the layout when weathered. Now, we used 3 different Acuflex paint colors for our weathering colors. They are sand, weathered black, and grimy black. Since you won't use much paint for weathering, use one of the paint cups. Fill it about 1/3 full of paint and add about 50% water to the paint to thin it for spraying. It's always good practice to test your paint pattern and volume before you apply it to the model. And then you're ready to weather. Dirt and grime will be thrown up by trucks onto the side and the end of the car, so we'll lightly weather the side first. Go easy and add more paint near the bottom of the car and less as you work toward the top. Do all the sides near the end of the car. Then airbrush the ends in the same manner. This dirt would collect here from cars in front or behind our car. Clean your airbrush between each color. Since AccuFlex is a water-based product, we'll use water to clean our cup and brush. Open and close your finger over the front of the airbrush, thereby forcing water back and forth between the tubes that go between the inlet and the nozzle. We'll use successive colors to weather the car and the roof. Remember, go lightly. It's easier to add more weathering than to remove it. It's important to clean the top of the paint bottle before you close it. And don't forget to add water to thin the paint before using the airbrush. Now we'll weather the top of the car. Again, spray very lightly. Just a dusting is all we'll need. Work from each end and angle the car so the entire roof is covered with a fine dusting of paint. Now, doesn't weathering add some additional realism to this car? Note how the weathering fades away toward the top of the car. Next, we'll take a Walther's car kit and repaint the car for our own road. It's best to paint the parts of the car before assembly because you'll save time not having to mask the other colors. We're using flat black and green for our car colors. Whenever possible, paint smaller parts when they're on the sprue rather than cutting them off. Use a very small amount of paint as you turn the part, making sure you get every portion. Heavy spraying causes the paint to drool. Use spring-loaded tweezers, twisting and turning small parts to assure adequate coverage. When the paint is set, grab the part at another location and spray the spot where the tweezers held it during the first spraying. Next, we'll spray the main frame of the car. This part has other pieces already attached. The coal load will look better black than yellow, so while we have black loaded in our cup, we'll spray the load. Next, we'll spray the car body. We chose a green color that will take several coats to cover the yellow. Move the airbrush back and forth, covering as much area as possible in each pass. Don't let the paint flow on just one spot. Now that the car is painted, it's time to letter it for our own road. We've cut some decal letters out for our road, the G, F, and P. We center these on the side of the car. Using the edge near the top as a straight guide and the rivets as a vertical guide, we'll place one letter between each row of rivets. Lay out the decal before you soak it in water to see where you want the letters to finally lay. Then, soak the decal in water for about 10 to 15 seconds and pick it up with the tweezers. Place it in the approximate final position and slide the decal off the backing with a brush. Use the brush to move the decal to the exact place you want it. The edge of a Kleenex will suck up excess water. We use Walther's Solvaset to secure the decal in place, and to hide the decal backing, apply a small amount with a brush and let it set for a few minutes. Then come back and apply a few more coats. Use Walther's Dull Coat to take away any shine. Next, we'll tackle a more difficult job, replacing both trucks and couplers on a car. Our truck snapped off, but some may be fastened with a screw. We'll have to fill in the hole where our old truck was mounted, so it will accept a small screw. We also will have to build up the space where our KD coupler will be mounted. Test fitting a piece of tubing shows that the hole will have to be drilled out. We'll also have to build up the area where the coupler will be mounted. Use a flat piece of styrene to position our coupler. We need to clean off the plastic tubing so it will have no flash on the end where it was filed flat. Then we place the tubing in a vise and cut off a 1/8 inch long piece using a jeweler's saw. You could also use an X-Acto saw. We'll need 2 pieces of this length. Square and clean off the end for the second piece and cut it off. Don't forget to clean the flash off the end of the cut-off piece. Our flat styrene is the right thickness to make the coupler pocket mount flush with the end sill of the car. It needs to be cut off to fit in the space where our coupler will be mounted. We'll measure the space, transfer that measurement to our styrene, compare it with the width needed for our coupler, scribe a cutoff line, and snap off the part. Clean up this piece and make another one for the other end of the car. Place a small dab of superglue on the spot where the styrene will be mounted. Use tweezers to place the part on the car underframe. A superglue accelerator will speed up the drying process. We also need to remove the lip on the top of the coupler pocket so it will fit on our car. You can file it off or cut it with an X-Acto knife. Either way, you'll need to file it smooth. KD instructions call for the coupler mounting screw to be a certain length in from the coupler box end. We will measure that distance in our car and drill a hole to accept a 256 screw. Use a sharp point scriber to indent the plastic where the hole will be drilled. Hand-holding the car can prevent damage while drilling with our drill press. Make sure you don't drill through the floor of the end sill. While we're at it, we drill out the truck mounting hole to accept the tubing. The drilling of the hole for the tubing will create some flash. Clean this off with a knife. Next, insert the tubing into the pre-drilled hole. If you measured correctly, the fit should be snug. Then, we drop a dab of superglue, making sure to fill the hole in the tubing as well. Filling the hole will allow a good, tight fit for the truck screw. Shortly, we'll drill the hole to fit the screw. We first must tap the hole for a 256 screw. Do this carefully so you don't break the tap, since you are not tapping the hole all the way through. The superglue will leave a few small bumps on our truck mount, so file those off now. Now, drill the hole to accept our truck mounting screw. The hole size will be dependent on the screw size you need for the truck of your choice. Now mount the coupler by first sliding in the centering spring, the coupler and the coupler cover, as we did on the car we built earlier. Make sure the coupler pivots easily. Next, mount the truck. We started our screw with a small screwdriver and changed to a larger one since the hole was tight. You want to constantly check the tightness of the truck to see that the car rocks from side to side just a bit. Now that the trucks and couplers are mounted, we want to check the height of the coupler to see that it meets NMRA and KD standards. We place the KD coupler height check gauge on the track and run our car up to the gauge. Well, now we have some rolling stock that runs well, looks great, and will offer us some running and switching possibilities later on. Good-looking and well-running rolling stock will help you enjoy your layout. Happy operation!